Okay, ladies and gentlemen, I am going to do a video and I'm just going to warn you. This is going to be one of my worst videos you've ever seen, simply because I'm not spending a whole lot of time putting the stoppers in it, so it's not going to flow as well as some of my other recordings, but you'll get the answers nonetheless. So let's begin with question number 1. It says to write it in interval notation. First of all, that's when you use brackets or parentheses. So since we have no equal sign here, that means we have a parenthesis here. And since we do have an equal sign here, we have a bracket here. For number 2, we're going to write it with a parenthesis because there is no equal sign. And infinity always gets a parenthesis. So that is why we have a parenthesis around the left-hand side. Question number 3, we are going to put a solid circle right here at -2 because of the bracket, and I'm just going to shade the number line that goes to the right. Now I can write this in set builder notation. I don't know why I drew a number line. Oh well, I guess it'll help us see this a little bit better. Set builder notation is our fancy notation. So we want to write it x such that x is greater than or equal to -2. Okay, I probably did the same thing with this one. Yes, I did. So set builder notation is going to look like this. X such that x is less than 9. Okay, moving on. Number 5. Now, evaluate the function. So it's basically saying, we're saying, what is the value of y when x is -9? So that's what I'm looking for. So here's what I did. I took out the x, and notice I put that negative right here. And I used parentheses because it's easier to see that. X is -9. So what that does is change that to a +9. So that's going to equal 17. And number 6, you're just going to simply, when you are looking at this right here, you're taking the opposite of x. So in our table, we're going to take the opposite of -2, which is +2, and add 1, and we get 3. The opposite of -1 is +1, and we'll get 2. And the opposite of 2 is -2. The opposite of 4 is -4, and so forth. Okay, so there you go. The domain is your set of x values, so I just highlighted that. And I started right here on the left and the right, but I'm not including those endpoints because they have hollow circles around them. Now, it doesn't tell me whether to put it in interval notation or set builder. So since interval notation is a little bit easier, I'm going to start there. And so it begins at -4 right here and ends at +4. And again, because those endpoints are not included, I used parentheses. You could have written it like this either way, but I'm not going to spend this video doing both ways. Okay. Oops, did I finish that? Yeah, I finished that slide. Let's go to the next one. The domain of this relation, again, this time the endpoints are included. So I'm going to use brackets, starting at -3 on the left and moving over to +2 on the right. All right, the range, this time I'm going to look at the y values. The highest point there is at 2, so I can say y is less than 2, or this is how I'd write it using interval notation. Right here, okay? You always put the lower numbers on the left, so we have to use -infinity on the left up to 2. The same thing for this one. Our highest point here is at this bar. I believe that's at 4. So y is less than or equal to 4. And the interval notation, again, you always put the lower number on the left. So since -infinity is lower than 4, we're going to do that. We're going to use the bracket because that point doesn't have a hole in it. All right? Absolute max and mins, local max and mins. So absolute means the highest That's the highest point. You just name it as an ordered pair. Hopefully, those numbers are really small, so hopefully I got those right. Absolute min, that's the lowest part of the graph. It happens to be there. Local means that somewhere in there you have other places where it changes from increasing to decreasing. So this right here is considered a local max. And there is no local min. So moving on to the next one. Where it's increasing, I'm going to highlight it. That's the interval where it's increasing. Now, this is where some people get really kind of messed up. You're using your x values, so you're capturing all these negative x values. So it's going to go from negative infinity all the way over to the number 4. Okay, that's the number 4 if you're reading off the x-axis. And then we're going to join it with this that starts at 0. And again, it's capturing all of the x values, the x number line here. Now, when it comes to those endpoints, you can just use parentheses. That was our rule we talked about. The decreasing part is that green part right here. And again, it's going to start at 4 and end at 0. So there you go. Next, positive and negative. Positive means above the graph. So we have two parts of this graph that lie above. That's the positive and this piece. So let's put those together. Again, we're reading the x-axis. So from -9 to -3. And then we have this little part over here. Starts at 9. The rest of this is going to go off into eternity. It's going to capture all of the x values. So we'll write infinity. And the negative intervals is where this lies below the x-axis. So again, we're starting here at -3 and traveling over here to 9. And again, we're using parentheses just simply because the where it hits 0, 0 is neither positive or negative. So right there is where it's changing out. It's neither one. All right, this is evaluate the functions at the given values. So what I'm going to do is this is asking me what is the value of y when x is -5. So I'm going to find -5 on the x-axis. I'm going to travel up here to the graph and read the y value, and it happens to be 8. I'm going to do the same for 1. I'm going to find 1 on the x-axis. I'm going to travel up here to the graph and read that number, and it's 5. Next, for 7, I'm going to find 7. I'm going to travel to the graph and read that number. It's at -1. Okay, this is a bunch of the same thing, so I'm going to kind of go through this fairly quick. You just have to figure out which graph or which equation to use based on the value. So if x is -8, I'm going to pick just one of these. Don't pick both of them. -8 is less than 0, so it's going to be plugged into this. -8 is not bigger than 0, so this one's disqualified. So 2 times -8 is -16. I'm going to do the same thing with the number 5. This time, 5 is going to use this equation because 5 is bigger than 0. So the answer for anything bigger than 0 is 0. Moving on. -8. You figure out which one of these equations -8 belongs to, and it looks like it belongs to that one, so it's equal to 6. +5 belongs to that one, so 2 minus 5 is -3. Same values, -8 belongs to this equation, so 2 times -8 plus 4 is -12. 5 belongs to the third one, so 5 squared is 25. -8 belongs to the first one because it's less than -5, so the answer is 15. 5 belongs to, let's see, it belongs to the third one, I believe, because 5 is greater than 1. And so 7 minus 5 halves is the same as 7 minus 2 1/2. Well, 7 minus 2 is 5. 5 minus 1/2 is 4 1/2. These are the exact same things. These are a little redundant. So I'm just going to zip through these. And here's your answers. Okay. There you go. Those are done the same exact way. This one's a little bit more in depth. You have to write an equation for each piecewise function, which means you have to write an equation for each one of these segments and then state the interval. So let's start with the first one, and you're going to have to use y equals mx plus b. Looking for the y-intercept, it's right here at -1, and the slope of this is -1 because you're rising 1 and going back 1. So it's going to be -x minus 1. The x values that it's capturing starts at -4 over to 0. Again, you're reading the x-axis. So -4 to 0. The point on the left always takes ownership of the endpoint, so that's why that's less than. This 0, there's a competition for that 0 right here. So both of them can't possess ownership of it, so it's the one on the left side that possesses ownership of it. So let's take a look at this second one. That's just a straight line, so it's y equals -1, and the x values that it contains starts at 0 and ends at 3. And again, notice I took ownership of the 0 because this one didn't, and this one I didn't take ownership of the 3 because the next one's going to. Now this is probably the toughest one, the third one, because we don't know what the y-intercept is. So what you have to do is you kind of have to create this little line to see where it would have hit if it would have been stretched out. And it would have hit at -4. I'm also noticing that the slope of this line is rise 1, run 1. So it's going to be x minus 4, and the interval, again, we're going to take ownership of that 3, and we're not going to take ownership of that 5 for a couple reasons. One is that there's a hollow circle there. Okay, the next one has 4. 1, 2, 3, 4. So the first one, again, we're faced with that same issue. We're going to have to drag this down to the y-axis. Now it does have a slope. If we read it, rise 2, run 1. So if I go this way, fall 2, go forward 1, fall 2, go forward 1, I'm going to have to use my imagination. It's going to hit at -7. The slope of that line is -2. Okay, the interval, the capture, the x values that are being captured here are all of the negative x values all the way up to -2. So this is the way I'm going to write that. X is less than -2. Okay, and then the next one is color-coded. This one's fairly easy. It hits at -1. It has a slope of +1, so that's going to be x minus 1. And the x interval that is starts at -2 and ends at 0. The -2 is going to be owned by that one, but the 0 is not. The next one is this line right here. It's pretty much the same thing, except for the slope is -1. So that's where I get -1x minus 1. The x interval starts here at 0 and ends at 2. And finally, this one is the one where we're going to have to extend that line down. You'll notice that the slope of this line is 1. Rise 1, run 1. So I'm just going to keep going with that, and it looks like it's going to hit here at -5. So the slope of that line is x minus 5. Where it begins is at 2 and ends at 5. It will take ownership of this 2 because the one before it did not. All right. Now, this next one's a little bit different because these things don't connect up, so you don't have to worry about who takes ownership of what. You're just going to read the endpoints. So the first one, again, we're going to have to extend this line, first let's calculate the slope. It looks like I'm going to go down 2 and back 1. Those are two negative directions, so it's a positive 2x. If I extend that up to over 1, it would have hit here at 4. So the slope of that, or the equation of that line, is 2x plus 4. And since this has a arrow on the end of it, that means that we're capturing all of these negative x's. So it's going to be x is less than -1. The second line, this one's pretty easy because we can read the y-intercept. It's at 3. The slope of this line is just -1. This is going to be -x plus 3. It starts on the left at 1. It owns that point, and then it's going to capture all of the positive x values. So we can say x is greater than or equal to -1. All right. Now we're going to graph these functions. All right, so we're going to graph y equals 6 and y equals 3x. And I'm going to draw a line at -2 because that's our place of where these two graphs are going to exchange equations. So when x is less than -2, the graph is going to equal 6. So there's 6. It doesn't own that 2 because there is no equal sign here. From this point, we're going to switch to 3x. Well, the y-intercept here is 0. So let me show you how I did that. The y-intercept is 0. The slope is 3, and this is tricky because it's counting off by 2's. So there you go. So from here, I'm going to go down 3 over 1, down 3 over 1, and that's where it begins, is right there. It owns that value because of that inequality symbol. Okay? Ooh, that's where I ended. Now I get to do it live. This should be fun. Okay, so again, I'm going to draw my line at 5. Oh, this is not good because we don't have, oops, that's bad. Oh, we don't have a grid there. So we'll just do the best we can. This graph on the left is going to be 12 minus x. So it's going to start at 12 right here. The slope is going to be -1. Rise 1, go back 1. Okay, I got to go until I hit this line. And we do take ownership of that because of the inequality symbol. All right, and then for the next line, I'm going to use this equation, which would have started at 2. So I'm going to kind of use my pencil. It has a slope of 1. So rise 1, run 1, rise 1, run 1, rise 1, run 1, rise 1, run 1. So it's going to start right about there. I don't know if you understood what I did, but I just basically, I'm going to erase these little dots right here because they're not supposed to be there. And then the graph has a slope of 1 from this point. So I'm going to rise 1, run 1, rise 1, run 1. And there you go. The only thing I did wrong here is that this should be hollow. And that red line doesn't necessarily need to be there either. So let me get rid of it. It really shouldn't be there, just to be honest. So I'm going to put a hollow circle right there, and it's as big as Texas, but I guess you get the gist of it. Okay. Oh, some more, yay. So when x is less than or equal to -2, so I'm going to start by drawing this line at -2, and this is where these equations exchange the baton, so to speak, and go from one equation to the other. So when x is less than negative 2, my graph is 2. So it's going to be, let's try to hit it right there. It is going to take ownership of that point. And then the next part of this graph is going to begin at negative 2, but to the right of that line, we're going to change it to this equation. So I'm going to actually start at 3 and then use the slope, rise 1, run 2, rise 1, run 2. But then I have to go back and kind of see where it would meet up with the red line. So I'm going to go down 1 and over 2, and it actually has the same joining point, and we don't have to worry about who takes ownership of it because the first graph already did. So I should probably erase that line, get it out of the way, and there's your answer. Okay, that was fun. All right, for the next one, I've got a couple different lines, it looks like. So I'm going to draw some red lines at negative 2. I'm also going to draw one, I think, at 1. So we've got like 3 sections. We changed the baton off 3 times. Alrighty, so the first equation is this, to the left of the first red line. So I am going to take ownership of it and just go that way, okay? Next, next I am going to do this. This should be fun. This has a vertex, and you can do your negative b over 2a if you want to, at negative 2, and the pattern points are over 1, up 1, and over 1, up 3. Now, the left graph, it doesn't own it, but it's already filled in. The right side, it is owned at negative 1, so I'm going to keep that a whole number, okay? And then finally, to the right of 1, we have this lovely equation. That should be fun. Negative 1.5 would be right about there, and then I'm going to rise 1, run 2. And rise 1, run 2, because it has a slope of 1/2. Rise 1, run 2. And so this line is going to hit at negative 1.5, and it is not owned. So I kind of have to put a little dot there, a hollow circle. Okay, let's connect those. There you go. That's kind of cloudy, but you get the point, hopefully. All right. Moving on. This is a long video. We're at 24 minutes already. Good grief. All right, this part should be fairly easy because we've done this so many times. All right, so we're going to describe the translations, and we're going to tell if it moves left, right, and if it's going up or down. Okay, so X always misbehaves, so this one is going to the left 1 and down 2. It is also going up. Okay, so the direction for it is up because A is positive. This one is just going down 4. No reflection. This one is going to the right 1. This one here is going down 4. This one is going to, X misbehaves, so it's going to the right 2 and up 2. This one is going to the left 7, and down 5. This one is going to the right 1 and down 1. And finally, the last one is going to the right 7 and down 5. Okay. And I think we're getting close to reaching the end of chapter 1. And I'm going to end the video after chapter 1 and start a new one for chapter 2. The average rate of change is slope. So you're going to calculate the rise and the run based on the interval. So beginning at -6 and traveling over here to 2, you're basically finding the slope of that line right there. Okay, so let me erase the mess. You're going to rise 1, 2, run 1, 2, 3, 4. Rise 2, run 4, which is, and you should reduce this, is 1/2. From -2 to 0, that's this line right here, because this is giving us the x interval, so it's saying from here to here. And that's that blue line that I just did. So the slope of that line is rise 1, 2, 3, 4, run 2. Rise 4, run 2. Rise 4, run 2. So the slope of that line is 2. Oops. From 0 to 5. So that's this line right here. It's negative. You're going to be going down 1 to the right 1. So it has a slope of -1. And remember, we use this AROC notation. Average rate of change. But that's slope. Okay, next we're going to calculate the values. We've done this earlier in this video. What is the value of y when x is -4? So I'm going to find -4. I'm going to drop down and read the y value, and it's -1. Next, what is the value of y when x is 2? -2, right here. Value of y when x is -2 is 0. The value of y when x is 0 is 4. And finally, the equations for the piecewise function, we've already done this before. It was the one that was not so easy. So let's start out with a big f of x equals, and we've got 1, 2, 3 lines to write the equation for. Let's start with this line right here. We'd have to extend it. Rise 1, run 2. It's going to hit the y-axis at +1. It has a slope of 1/2. So that would be 1/2 x plus 1. And that's on the interval from -6 all the way over to -2. Okay? And then we're going to find the slope, or excuse me, the equation of this line, which we already found the slope was 2, so that's going to be 2x, and it hits at 4. The y-intercept here is at 4. And the interval, again, you're reading the x-axis, begins at 2 and ends at 0. Begins at 2. 2 takes ownership of it and ends at 0. And last, we're going to write the equation of this line here. And we already know that the slope of that line is -1, or just -x, and it also goes through the y-intercept of 4. It begins at 0. 0 takes ownership of it, and it ends over here at 5. Now we are going to let 5 take ownership of it because there's nothing to the left, to the right of it, excuse me. And I believe that concludes, that concludes this video, and it's only 30 minutes long. All right, so I'll begin the next video shortly.